Hi, Joe Cerrone and Francis Barrar in our weekly Zoom classroom meeting for CNC Machining Operations. All right, we're up to mill lesson 6, and we're going to go all the way to mill lesson 10. So 6 is where we start actually getting more of the programming now that we have the ability to set up the offsets, program the tool changes, and basic G-code programming. So we're to complete the middle lesson 6 programs, turn them into the assignments folder, and then students who'd like to take the NIMS test can schedule lab time to start working on the credentialing report. So if you'd like to come in, email us and we'll set up some time for you. When we talk about the credentialing report, that was posted last week in middle lesson 5, and here's the credentialing report. And so if you click on this, what you can do is you can print this out and bring it to school, and then Francis and I will take you through the operator level 1 task list. And so things like being able to understand where the safety items are, like the fire extinguishers, MSDS, material data sheets on chemicals within the lab, safe lifting practices, just general safety overview. And then from an operator standpoint, we want to power up the machine, set up the offsets, and be able to run these basic programs. So from an operator standpoint, if you're going to take the test, you will need this student achievement record or credentialing achievement record filled out. We figure it takes 2 or 3 classroom visits to get yourself set for a NIMS credentialing report. And then as we go through, we're going to continue to work on these programs. And so here's part number 2, and there's 13 parts altogether in the CNC program. I think 14 actually, that we will complete, and then we'll switch over to the lathe and do it all over again. Today we're going to look at, in our hands-on lab activities, how to use a presetter. Presetters save a lot of time, and so we'll create a video, and we'll also go through and work with the operators. And so we're starting to do more lab work, but the idea is to get you guys comfortable with setting up the machine and running the programs. If we look at mill lesson 6, mill lesson 6 is right here. Straight line linear interpolation. And as we work with the straight line linear interpolation, we do a lot of calculating again, where we go through and calculate the coordinates for position number 1, position number 2, 3, etc. Since this arc is the same radius as the tool, there's no, this would be a counterclockwise G3 move if the arc was bigger, but since it isn't, we don't need a G3 in there. But what we do need to do is to calculate the center line of the tool. And so as we look at how these programming are, what they're doing is they're programming to the center line of the tool, where you have to go through and look at the tool that you're using and the radius. So the cutter diameter is 1/2 inch, radius is 1/4 inch. So if we were at 0.75 from the origin, we would take off 25, and we would be at 0.5 for point number 1. And then in the y-axis, we would do the same calculation off of the 0 position. So we would be 1/2 inch up, and then we take 1/4 inch off. And so we would add y 0.25. Remember to use your decimal points as you go through and you work these programs. And then we'll write this program right here. So as we look at the program here for part number 5, we're going to set up the stock as 3 inch by 3 inch. And then it's a really very straightforward program. We're going to use the CNC Easy simulator. You're also available to use the back plotting software that comes with the CNC programming kit. But we don't use that in school because the CNC Easy Pro is just much easier to understand. So as we look at this program here, we just have position 1. If we look at the way that this part is set up, it's just going to plunge here, move to this position, and then move to this position. It's really a very easy program. And then what we'll do is we'll calculate those coordinates. Here's your X position. And so X1 is going to be 0.75 over and 2.5 up from the origin. Point number 2 is calculated. Point number 3, very basic stuff. And then here's our program. And so you will write the program with Notepad. You don't necessarily need to turn in the simulation. Those of you guys who've been doing all the work, I graded everything, and programs look terrific. Everybody seems to be on task with this. So if we look at program number 5, I've already started it in CNC Easy. So what I did was I went through and I set up my workpiece. Now, if you need instructions on how to access the lab, I will post that so that you can VPN into P130 to use the simulator. You can also use the backplotting software, so it's not that big a deal. But this is just a more graphic software. And so here's my part number 5. What I did was I set up the stock as 3 inches by 3 inches. And then I went through and I set up the machine setup, because the way that they're programming these parts is they're picking up the work registers for G54 in the center of the part. So as we worked last week to set up our G54 with the edge finder, when we tie it into the simulator, the origins need to match. The other thing that needs to match is the tooling. The guys that are writing the programs, make sure that you call out which tools are in which current location. So tool number 4, commenting out that that 1/2 inch end mill is extremely helpful. We want to include that information in the programs. Everything else is pretty much boilerplate. So if I go through and I want to set up the tool turret, what I would do is I would set up tool number 4 as a 1/2 inch end mill. So I come down to tool number 4, turn slot 4, and then I locate a 1/2 inch end mill. And then I add that tool, I save it, continue to save it, say yes, and we okay it. Then when we go through and we run the part, we'll run the part in automatic mode. We'll set it up for a single block. And then we click on this green button. And every time we click on the green button, it goes through and verifies our program. First line of code is a %sign, meaning that it's a start flag. It prefers the control for the program. This is a comment. It just tells people what the program is. It's a good idea to put your initials on here and that's your program so that people know whose it is in the control. G20 inches. And then our standard setup, canceling of codes, setting up the XY plane. Tool number 4 comes into play. Here's our tool change, T4M6. I usually tell people right here in comments or in parentheses to put the tool. Here's our G90, G54, X position, Y position, spindle speed. If I've set up my offsets correctly, here's my G43 height offset 4, and then it's going to ramp at 100 thousandths over the part, and then it's going to go through and create the part. And it doesn't look like I am in the right origin for that, so I'm going to go back into my machine setup, work registers, and I'm going to zero these out, see if that was what it was. So we'll go on here, zero that, here, zero that, apply it, okay, and then what we'll do is we'll stop the program, go to automatic mode, bring it back to the top of the screen, go back into run mode. Let's try it now. Okay, so it's my workplace register. Again, it's always something with these programs. It's very unusual to get it to work perfectly on the first time, but troubleshooting and diagnosing your errors is part of the program. So that's our first part that we will cut. It's just a simple linear program where if we go through and we rewind it again, let's see. We start off with our G20, meaning that we're in inches, standard setup, where we cancel our programs for. So you want to know what these G codes are. We're in rapid mode, XY plane, canceling cutter compensation, canceling tool length offset, canceling can drilling cycles. And then we're in absolute programming mode. And so the idea will be that students will go through and set up these programs in the machine, and then we'll go through. If I want to go through and set it up for the next program, we can take a look at that. Part number 6. So part number 6, again, we have to go through and look at the geometry and how we're going to calculate that. XY0 is set up in the lower left-hand corner, so I don't need to change my offset registers. When I'm picking up my G54 or G55 or G56, remember those are part origins. And so it's not unusual for companies to have multiple vices or multiple fixtures in the machine, and then to have that run for hours at a time. And so by having the work offset programmed, we understand how to have multiple parts in there where we can run the same program at G54, G55, etc. So with that, we can look at program number 6. If we go into our simulator, what I'm going to do is I'm going to close this, and then I'm going to open 6 text file. Okay. Actually, I didn't want to. Actually, I can just make this work. I think. Let's see. Okay. So let's open 6. All right, and then I want to go through and I want to look at my tooling again. Okay, so again, I just have a flat end mill for tool number 4. That's a 1/2 inch. If I go through and I edit my tool turret again, tool number 4, just verifying it's a 1/2 inch end mill. I'll say okay with that. And then as we look at it, I do like these blue comments where you can actually go through and look at it. I'll oftentimes mark them A, B, C, or D instead of 1, 2, 3, and 4, just because there's a lot of numbers. Go back to automatic mode, start it off again. And I think there's a way to show colored tool cuts on this. Let's see if I can figure out where that is. Colored tool cuts will enable it. Much easier to see. Let's run that one more time. So we'll go back, turn off automatic mode, turn it back on. Start off at the first line. Again, read the program to yourself. You should be able to see it. If you're operating the machine, that's where we're going with this. And so as we go through and we work with an online manufacturing course, and this is where everybody's going with these courses. It's not that they're better or that they're really great. It's that it's deliverable. So we were in a meeting last week with companies. We were with a meeting with the TMA last week, and they're looking to be able to deliver because they deliver online courses because they have people that are in other countries. They have people in Mexico. They can't necessarily come in for all of the programming. And so by having virtual simulation, we can get ourselves up and running. And so that's program number 6. Again, know your G and M codes. And then as we look through and look at some of the other programs, if I were to go and open up another one, let's take a look at what 7 looks like. And I'll tell you what, you guys, as far as getting these programs done, you can do 3 of them. You don't have to do all 4. We'll make the 4th one bonus. So we're in October. We probably have 2 or 3 more weeks of nice weather. And then once the weather's gone, that's not to say that you guys can't do all of them. Granted, the more programs that you do, the better you will get at it. And so program number 7, again, we verify that's our correct end mill, and then we can go through and simulate the program in automatic mode. sure what my error is on this one here. Let's see what happened with that. G0, G90, G54, X is a decimal, Y is a decimal. The A-axis would be for turning. You'd be able to turn that. Spindle speed. Sometimes you have to look at the line before it or the line after it. I'm not sure if I'll be able to troubleshoot this during the middle of the Zoom meeting. So at this time, I'll come back to it. Let's take a look at some of the other work that we have lined up. So program parts for lab number 6, linear interpolation. Go through and write the program for 3 of the 4 programs. Turn in the notepad file to the assignments folder. And then you can move on to module number 7, which is circular interpolation. Today our plan is to go through and to look at the presetter, and we'll make a video. And we're really kind of moving along today. I think what we'll do is we'll move into that video earlier today than later. We typically were going into that at 10 o'clock, but I think we might go in there earlier. The other thing that we're working on is the Immerse to Learn homework. So you should be completing the 3-axis milling machine setup, and you need to take the assessments in there. And we're able to go through and grade you on that. And so if you look at the CNC from Immerse to Learn, here's the course. I've already logged in. And then if I take a look at my 3-axis milling machine setup, here I am, and we're in the manual operation. Now, the simulators and everything works here at the college. So you're welcome to come in and work in the lab. If you're going to install it on your own computer, it can be a little bit tricky because they've disabled Flash or they've discontinued Flash, and it seems to run on Flash. Our IT department has this program set up, but if I wanted to, I could go here. Since I'm in the class, students would go to downloads, and what you would do is you would download the Learn CNC latest, and that will install the simulators. What you will get is you will get a Learn CNC link on your desktop. So I think it's called Immersive Engineering right here, and then you can run it, and what it'll do is it'll launch the web browser and the simulators. So if I come back here to my home screen, Learning CNC, 3-axis milling machine. Am I okay? So we'll go to look at how we would go through and run it. There it is. Thanks. Applications, and then we can run the Haas Vertical Machining Center VF3. We open it, and then we can go through and simulate our programming this way also. Everything from powering on, so we can say power on, and then we can go through it just like it's in the curriculum. So we can reset it a couple of times. Until we clear the alarms, and then we can go through and start to work with the programming. This by no means is as good as hands-on programming, but it does have the control, and it does have all the information that you need to be able to successfully simulate a Haas. And going through the tool changing, everything looks terrific. Not terrific, but it works. It's deliverable from that standpoint. And that's what we're looking to do. So if we come back to the mains, so if we take a look at this, essentially what we want to do is we want to go through the operations, hand jog mode, spindle speed control, changing tools, then do the module review and take the post test. We will get the information automatically graded, and we will use that for your grade. So everybody's doing really well in the course. You guys are turning in the work. Just stay on task. Make sure that you continue to do the work so that you get your money's worth out of the course. And that when you're done with it, you have basic operations of the vertical machining center and basic operations of the lathe. And like I said, we'll do 14 programs on the mill. So as we go through, we'll continue going through these lessons and turning those lessons in. And then the hands-on application will start after we do our main lecture. So I'm going to stop this recording. We'll open things up for questions, and then we'll take a short break and we'll get things set up so that we can actually go through and show how to use a presetter, and that anybody who's here who wants to do the operator's certification can do that. I have 2 lab assistants. Young is here today, and Francis is the co-teacher. So between the 3 of us, as long as you tell us that you're coming in, we can be prepared for it. So with that, that's our weekly Zoom classroom meeting. Work on mill lesson 6. Turn those into the assignment folder that will be due October 7th. And then the subsequent mill lesson 7 will be due 7 days from that. That will be due October 14th. I'll populate the calendar as we continue to work on this. With that, that ends our weekly Zoom meeting. I'm going to stop the recording and open things up for questions.